Okay, so this experiment is on centripetal force, and let me pull up the document so we can work with this side by side. The document can be found in your course content area, and is titled Centripetal Force. Okay, so centripetal force simulation. So on the right side is the actual simulation. It can be found on thephysics.aviary.com. I need to make that correction. And basically what we're going to do is we're going to see the relationship between the inward force, which is that centripetal force, and the spinning rate at which this thing goes around. So in the simulation, what you're going to do is you're going to be filling out these tables here, these cells. And so let's go ahead and do that and follow the steps here. Essentially, what you're going to do is you're going to just follow these directions. Keep in mind that each one of the up here, number 2, each one of the washers that you see over here represents 10 grams. So right now it looks like I have about 80 grams. Also keep in mind that you want to deal with SI units as well. So SI units in terms of mass are kilograms. So you're gonna have to kind of factor that in. So without me giving away too much of it, I'll let you think about that. So most of this stuff is fairly self-explanatory, but in terms of the operation of this simulation, it's a little bit tricky, and we've probably dealt with 1 or 2 simulations that have this little flaw, and that being that we can't always get exactly to the right, the perfect mass that we wanted to, if we wanted to recreate the simulation. So for example, let's say I'm doing the simulation at 85 grams, and I come back maybe the next day, I'm going to probably have some issues in terms of getting to that 85 grams. So periodically you can get there, but when I have to recreate it, sometimes I have to kind of jostle a little bit, and you can see there, I can get to 86, and I just work from that perspective. Okay, so what's going to happen here is you're going to be able to change the length of this string. So right now it's just sort of a frozen frame of this object, which as you increase the mass, the ball size gets bigger. We can also change the length of this string. So we have the string going around, and we can change the length by clicking on this little tab piece here. Also, again, sometimes it's a little bit tricky to get exactly to that specific number. So let's just say you had a length of about 100 centimeters. It might be kind of hard to get precisely there. So you have to this is just a really rough estimate in terms of how we get there. I mean, this could be 100 centimeters. It could be, 99 centimeters. So just do the best you can. Okay. The other variable that you're going to want to change is the number of washers. And to do that, again, just click on the washers. Same thing is going to happen. You're not going to always get to that perfect number of washers. Do the best you can. Okay. So once we set the mass, the string length, which we'll call R, and the hanging mass here, what we're going to do is we're going to start this this object to spinning. And so my suggestion is you go through about 10 revolutions. So I'll go ahead and start it. And so you can see there's 1, there's 2, there's 3. And as this thing goes by, which you're going to have a hard time seeing, there's 5. It's going to be hard to kind of see the depth at which this thing is. So I think that's 6, and 7 and 8 and 9, and hopefully I got to 10. All right, so looks like I got this, fairly close. And so it looks like for 10 revolutions, we had a total elapsed time of 2.8 centimeters. And what we found now is we found roughly that the period is about 2.8 seconds. So one period represents one full revolution. So the time to go through one full revolution constitutes a period. So obviously you can do this over, any number of times. So let's just say I wanted to reset it. I would probably need the same variables. And then I would go through it again. So that would be the first part of this. So my suggestion is use 10 revolutions, gives you a good feel for how this works. So once you do that, you're going to plug in all this information into our chart here, our table, and so you'll plug into this table and you'll fill in with the various pieces of information. So keep in mind here, you're going to have to do some calculation. Make sure you distinguish between weight and mass. I'll leave that one up to you to think about. R represents the length of the string that is spinning around, the radius. T is the period. Then you'll repeat this again. Follow the directions, answer the questions, and then you're going to stop at this particular point. Okay, so just to give you a little background information, a little bit in addition to what you're going to be seeing from the lab. You're probably going to see this in your lecture, but F sub C is equal to our centrifugal force. And by definition, it's equal to m v squared. This is the linear velocity of it. So I'll talk about that in just a second, all over R. Okay. So excuse me, kind of getting used to this new pen here. And so what you'll see is obviously here, the force is going to be in newtons. And you'll have some mass and some velocity. So let's see if I can draw a quick picture here. Do my best. So there's that circle in which something is going around. So let's say we go counterclockwise, and let's put an object there. Put a red ball. Draw a ball here. So this will be our object. This will be the center of our circle, and let's just say that this has a radius of R. And so as this object goes around the circle, it's going to create a centrifugal force. Now that centrifugal force could be, it's going to be found in the spinning source itself. So in this case, it's going to be that cable or that rope, and that centrifugal force is going to be specifically called the tension in this particular case. So I wouldn't use T for this particular experiment because we've already allocated T for period. So I don't know, you could use something other than T. Let's just say that you use, sorry, get rid of all that mess. Let's just say you use something like, oh, I don't know. How about script T? Something that looks something like this. All right, so just use something other than big T because it's going to get it's gonna get confusing. We ran out of letters in physics, or you can just simply use S of C. Okay, so that's the experiment in a nutshell. Make sure that you work individually. This is an individual project. You're free to converse with your counterparts, your classmates, your colleagues, but make sure that you have unique answers. All right, if you have any questions or concerns, feel free to give me a call. 791-2503, area code 727, or you can email me. Take care.